Question 15. The time taken to complete a journey varies inversely with the speed of a car. A car takes 6 hours to complete a journey when travelling at 60 kilometers per hour. How long would the same journey take if the car were travelling at 100 kilometers per hour? Now with inverse variation, when one variable doubles, the other variable halves. So if the speed were to double, the time taken to complete the journey would halve. Now from 60 kilometers an hour to 100 kilometers an hour, that's almost double the speed. So we'd expect the time taken to complete this journey to be close to 3 hours. It'll be a little bit above 3 hours, but let's work it out precisely. The first thing we're going to work out is the distance of the journey. The car is originally traveling at 60 kilometers per hour over a time period of 6 hours. So the distance is 60 multiplied by 6, which equals 360 kilometers. Now to work out the time taken to complete the journey of 360 kilometers at a speed of 100 kilometers per hour. So time taken to complete the journey is equal to the distance divided by the new speed, 100 kilometers per hour. And that equals 3.6 hours or 3 hours and 36 minutes. So the answer is option D. Question 30b. A golf ball is hit from point A to point B, which is on the ground as shown. Point A is 30 meters above the ground and the horizontal distance from point A to point B is 300 meters. The path of the golf ball is modeled using the equation h equals 30 plus 0.2d minus 0.001 d squared, where h is the height of the ball above the ground in meters and d is the horizontal distance of the golf ball from point A in meters. The graph of this equation is drawn below. Part 1. What is the maximum height the ball reaches above the ground? Now the vertex of the parabola represents the maximum height of the ball above the ground. So locate the vertex and from that point project across to the y-axis, and we can see here that the maximum height of the ball above the ground is 40 meters. Part 2. There are two occasions when the golf ball is at a height of 35 meters. What horizontal distance does the ball travel in the period between these two occasions? So firstly, let's locate 35 meters on the y-axis. Then we're going to draw a horizontal line across with a ruler and find the 2 points where it intersects with the parabola. So there's a point here and a point here. From these 2 points, we're going to project downwards, parallel with the y-axis of course, until it strikes the x-axis, and it's going to strike the x-axis here at these 2 points. The x-axis represents the horizontal distance. So the two horizontal distances that we have, 170 meters and 30 meters. And part 2 asks for the horizontal distance between these two occasions. So 170 minus 30 is equal to 140 meters. Part 3. What is the height of the ball above the ground when it still has to travel a horizontal distance of 50 meters to hit the ground at point B? Let's locate point B. So that's point B there at the 300 meter mark. Go back 50 meters. So 300 minus 50 is 250 meters. So locating that point on the x-axis, we're going to draw a vertical line straight up till it strikes the parabola. And from that point, project across to the y-axis, and then we can read the height of the ball above the ground from the y-axis. So that corresponds to 17.5 meters, or roughly 17.5 meters. Part 4. Only part of the graph applies to this model. Find all values of d that are not suitable to use with this model and explain why these values are not suitable. Let's go back to the graph. This is point A, so this is where the golf ball starts, and this is point B where the golf ball ends. So this point here, the golf ball's on the ground. At this point here, it's on the top of a cliff. Now, since the golf ball starts at this point, it makes no sense to have negative distances. So in fact, the journey of the ball starts here, so values of d less than 0 are not suitable. Now the golf ball ends its journey at this point here. And for the same reason, it makes no sense to have values of d that are greater than 300, since this is the point where the golf ball stops. In fact, values of d greater than 300, according to this model, indicate that the ball is in fact underground, and that's not the case. So this model is only valid for values of d between 0 and 300, including, of course, 0 and 300. Question 30C. In 2010, the city of Pythagoras modelled the predicted population of the city using the equation P equals A outside of 1.04 to the power of n. That year, the city introduced a policy to slow its population growth. The new predicted population was modelled using the equation P equals A outside of B to the power of n. In both equations, P is the predicted population and n is the number of years after 2010. The graph shows the two predicted populations. Part 1. Use the graph to find the predicted population of Pythagoras in 2030 if the population policy had not been introduced. So let's refer back to the graph. We'll locate 2030 on the x-axis. From that point, project upwards until we strike the dotted line, because the dotted line represents the population growth of Pythagoras if the policy had not been introduced. So where it strikes the dotted line, project across to the y-axis, and then using the grid, read off the population, which is 6,600,000. In part 2, in each of the two equations given, the value of A is 3 million. What does A represent? Let's locate 3 million on the y-axis, and notice that it corresponds to the year 2010. So A represents the initial population of Pythagoras. Part 3. The guess and check method is to be used to find the value of B in P equals A outside of B to the power of n. 1. Explain with or without calculations why 1.05 is not a suitable first estimate for B. Now, part of my solution here, I've written that B needs to be less than 1.04, since any value of B greater than 1.04 implies a faster population growth. Referring back to the graph, this is the value B equals 1.04, and that results in this dotted curve. If the value of B is greater than 1.04, rather than getting this solid curve here under the dotted curve, we'll end up with a solid curve above the dotted curve, which indicates a faster population growth. So we need a value of B that's less than 1.04. Part 3, 2. With n equals 20 and P equals 4,460,000, use the guess and check method and the equation P equals A multiplied by B to the power of n to estimate the value of B to 2 decimal places. Show at least 2 estimate values for B, including calculations and conclusions. Now the value of A is 3 million, and we're going to use that and the value of n, and we're going to get some values of B to try and get a number for P very close to 4.46 million. Now the value of B needs to be less than 1.04, and that's been established earlier. So let's guess B equals 1.03. Let's check that. 3 million multiplied by 1.03 to the power of 20 gives around 5.4 million, which is definitely too high. Let's guess B equals 1.02. Let's check that. 3 million multiplied by 1.02 to the power of 20 gives 4.457 million. So pretty close to 4.46 million. I think that's very close, but let's check another value of B. So let's check 1.01, and that would just add a little bit more weight to the argument that 1.02 is our best guess. So guessing B equals 1.01 and checking that, 3 million multiplied by 1.01 to the power of 20 is around 3.66 million, which is definitely too low. So the value of B would be 1.02, correct to 2 decimal places. Part 4. The city of Pythagoras was aiming to have a population under 7 million in 2050. Does the model indicate that the city will achieve this aim? Justify your answer with suitable calculations. Now we're going to let n equal 40. Now where does that come from? If we go to the graph, when n equals 20, that corresponds to the year 2030. When n equals 30, that corresponds to the year 2040. So therefore, when n equals 40, that corresponds to the year 2050. So letting n equal 40, We have the value of A, which is 3 million, and we found our value of B, which is 1.02. Value of N is 40, of course. Substituting all that into this formula here, we end up with 6,624,119. That's correct to the nearest whole number, which is definitely less than 7 million. So therefore, the city will achieve its aim based on this model. Question 22. Leanne wants to build a rectangular vegetable garden in her backyard. She has 20 meters of fencing and will use a wall as one side of the garden. The plan for her garden is shown, where X meters is the width of her garden. Which equation gives the area A of the vegetable garden? So firstly, we have 20 meters of fencing, which encompasses these three sides. So that's two widths and a length. Now, in order to work out the area of the vegetable garden, and this being a rectangle, of course, we need the length and, of course, the width. So let's work out the length first. And the length is worked out by taking 20 meters, which is the total amount of fencing, minus X, which is one of the widths, but then we need to subtract X again, which is the other width. And combining the like terms, we have length equals 20 minus 2x meters. Now to work out the area, we take the width and then multiply it by the length. So area is equal to 20 minus 2x multiplied by x, and expanding the brackets, so multiplying the x by each of the terms inside the bracket, we have x times 20 is 20x, and x multiplied by negative 2x is negative 2x squared. So the expression for the area of this vegetable garden is 20x minus 2x squared, which is option D. Question 3. The diagram shows the graph of an equation. Which of the following equations does the graph best represent? Now this U-shape curve is called a parabola, and that corresponds to an equation where the power of x, or the highest power of x, is a 2. And option C is the only equation where the power of x is 2 and it is also the highest power of x. So it's option C. Question 26D. Solve these simultaneous equations to find the values of x and y. We have y equals 2x plus 1 and x minus 2y minus 4 equals 0. Now we can use either elimination method or substitution method. The elimination method works best when you have the same term in both equations that you can either subtract or add together to eliminate them. But we don't have that. What we do have though is we have y as the subject of the formula in the first equation. And that will make substitution method a lot easier to use. So that's what I'm going to apply here. So using the substitution method, what I'm going to do first, just to make it a little bit easier for myself, is I'm going to start with the second equation. And I'm going to write it as x minus 2 outside of y in brackets. All I've done is I've just added brackets around the y. Minus 4 equals 0. And the reason for that is because I'm going to substitute out the y, and in its place, I'm going to substitute in 2x plus 1, since y and 2x plus 1 are equal in value based on the first equation. So I'm going to substitute out the y, and in its place I'm going to write 2x plus 1 in the brackets, and that's the significance of adding the brackets around the variable that is going to be substituted out. So now we have an equation involving the variable x only. So x minus 2 outside of 2x plus 1 in brackets minus 4 equals 0. We'll expand the brackets there. And we get x minus 4x minus 2 minus 4 equals 0. So that's minus 2 times 2x is negative 4x. And minus 2 or negative 2 times positive 1 is negative 2. Minus 4 equals 0. Now let's solve this equation. So we'll collect the like terms. So x minus 4x is negative 3x. And negative 2 minus 4 is negative 6, and that equals 0. I'm going to move the negative 6 over to the other side by adding 6 to both sides. So we have negative 3x is equal to positive 6. Dividing both sides by negative 3, we have x equals 6 divided by negative 3. So therefore, x equals negative 2. Now that's only half the solution. We still need the y value that corresponds to that. So we can use the first equation for that. Since y is already the subject of the formula, all I need to do now is just substitute x equals -2 into the first equation to then find the value of y. So y is equal to 2 multiplied by -2 plus 1. So in place of the x, substitute in the value -2 plus 1, and therefore y is equal to -3. And therefore the solution is x equals -2, y equals -3. Question 29a. The cost of hiring an open space for a music festival is $120,000. The cost will be shared equally by the people attending the festival, so that C in dollars is the cost per person when n people attend the festival. So part 1, complete the table below by filling in the 3 missing values. So the values are found by taking 120,000 and then dividing it by the number of people attending. So it's one of those situations where the more people that attend, of course, the cost is shared, so the cost should be cheaper per person. So 120,000 divided by 3,000 will equal $40 per person. 120,000 divided by 2,500 people will equal $48 per person. And 120,000 shared among 2,000 people results in $60 per person. So to find the cost per person for the number of people attending when there's 500, 1,000 or 1,500, again we follow the same pattern. 120,000 divided by these 3 values, you'll get $240 per person for 500 people attending, $120 per person for 1,000 people in attendance, and $80 per person for 1,500 people in attendance. Okay. We can also see that for 1,000 people, it's $120. If you double the number of people, so $2,000, it should be half the cost. Now, one way to check your answer would be if you take the cost per person and then multiply it by the number of people, you should get $120,000. So in fact, 240 times 500 will give you $120,000. 120 times 1,000 will give you $120,000, and so on. Let's have a look at part 2. Using the values from the table, draw the graph showing the relationship between n and c. Now, the top row of the table of values corresponds to the x-axis or x-axis coordinates, and the bottom row, of course, corresponds to the y-axis or y-axis coordinates. So I'll just reveal the graph, and it should look something like this. Okay, so each column represents a coordinate pair. So for example, 500, 240. So locate 500 on the x-axis and then project upwards until you reach 240, mark a point, and then just mark all the points in turn that correspond to all the columns, and then just a neat sketch of the graph there. Okay, let's have a look at part 3. So what equation represents the relationship between n and c? So it's clear that the number of people in attendance, the more people that attend, the less the cost or the lower the cost per person. So this is a type of inverse variation relationship. So c varies inversely with n, so it'll follow an equation which looks like c equals k over n, where k is the constant of variation. So as n gets bigger, c gets smaller. And k, of course, is 120,000 because k is what is shared among n people. So the equation would be c equals 120,000 over n. Part 4. Give one limitation of this equation in relation to this context. Now this is an open-ended question, which means there's more than one correct answer, and you only need to state one limitation. I'm going to go through a few suggested solutions, so there's obviously more than this, but these are the ones that I came up with. So if one person attends, the cost for that person will be $120,000 according to the model, which is unrealistic given the context, which is a music festival. So it doesn't make sense for one person to attend. Another limitation would be that n is limited by the capacity of the venue. So we can't have an infinite number of people attending. So there needs to be also an upper limit to the number of people in attendance. N must be a positive integer. Doesn't make sense to have a negative 10 people attending or 100.2 people attending, and so on. And part 5, is it possible for the cost per person to be $94, and support your answer with the appropriate calculations. So we need to work backwards. So we're going to use the inverse variation equation. C equals K over N, where K is 120,000. And we're going to solve for N. So if the cost per person is $94, we know that to hire the venue is $120,000. So let's solve for N. So how many people would need to be in attendance so that each person pays exactly $94? So solving for N, if you multiply both sides of the equation by N, we have 94N equals $120,000. And dividing both sides by 94, so to make N the subject of the formula, so N equals 120,000 divided by 94. And we get N equals 1,276.5957 and so on. So it's a decimal answer. But we've seen before that N represents the number of people. So it does not make sense to have 1,276.5957 people attending. So N must be a whole number or a positive integer since it represents the number of people. So therefore, it is not possible to have a cost per person of $94. Question 5. Which of the following graphs best represents the equation y equals x cubed plus 1? Let's have a look at the 4 graphs. Let's have a look at option A. A straight line is represented by an equation which resembles y equals mx plus c. Let's have a look at option C. This is a graph that is exponential. In other words, it starts off sort of a very low values of sort of very low values here, very close to the x-axis on the left-hand side. And as you move from left to right, the graph gets sort of steeper and steeper and higher. The values of y, the vertical values, just start increasing, in fact, at an increasing rate. So this could be the function y equals 2 to the power of x. The equation y equals 2 to the power of x. Option D. This is like a U shape. Okay, we give those a name. There's a very special name for that, which is a parabola. It could be sort of a concave, what we call concave up or concave down, where it's sort of a sad face, sort of happy face type scenario. This one's a happy face. This one is of the form something that involves an x squared plus c. So none of these 3 options, in fact, resemble the equation in the question. X cubed gives you a characteristic, almost like an S or a Z shape if you turn the graph on its side. So turn it that way. You can see kind of what resembles like a letter Z. Anyways, move it back the right way. So it's clearly this one here. This one is y equals x cubed plus 1. 1 is the y-intercept. So it passes through the y-axis there at y equals 1. So it's option B. Question 27C. Ariana's parents have given her an interest-free loan of $4,800 to buy a car. She will pay them back by paying X dollars immediately and Y dollars every month until she has repaid the loan in full. After 18 months, Ariana has paid back $1,510, and after 36 months, she has paid back $2,770. This information can be represented by the following equations. So part 1, solve these equations simultaneously to find the values of x and y. So we could use the elimination method here, or you could use substitution method. I mean, either one's fine. But I think it's easy enough to see that if we, I'm just going to label these equations, if we take equation 2 and subtract from equation 2 equation 1, we could come up then with an equation that eliminates the x, and we can just find the y on its own, and then we can substitute it back into equations 1 or 2 to then find the values of x. Okay, so if we just do the 2 minus 1, okay, let's see what happens. So 2770 minus 1510, okay, and we also have 36y minus 18, so we'll do both of those. So 36y minus 18y, well, it's equal to 18y. Since x minus x is 0, so that's eliminated. And 2,770 minus 1,510, we have 1,260. So 18y is equal to 1260 dividing both sides by 18. Y is equal to 1260 divided by 18. Therefore, y is equal to, okay, divide that by 18, is equal to 70. So that's $70. That's actually Y dollars per month. So she's paying back $70 a month. Now let's find the X. So from, you can pick any equation, you can use equation 1 or equation 2. Let's say from equation 1, okay, we have X plus 18Y. So 18 multiplied by 70, since we've now found the value of Y, is equal to 1,510. Okay, let's solve now for X. 18 multiplied by 70 is 1,260. So X plus 1260 is equal to 1510. X is equal to 1510 minus 1260. So just algebra now. Okay, and 1510 minus 1260, we have 250. Okay, if you can just see that there. Okay. So just summarizing the results, therefore, X is equal to $250 and Y is equal to $70. So part 2, how many months will it take Ariana to repay the loan in full? So we can use either one of these two equations. It doesn't really matter. We can form our own even. We know that Ariana is paying X dollars per month. Actually, I'll just go back to the original question. She's paying X dollars, immediately and Y dollars every month until she has repaid the loan in full. And she borrowed $4,800. So let's just form another equation now. So we have X plus, okay, so this is, let's say N multiplied by Y is equal to $4,800. We have values for X and Y now. So X is the amount that she pays immediately, which is $250, plus N multiplied by, so N is the number of months multiplied by the amount that she's paying every month, which is $70 a month, is equal to $4,800. Now we need to solve for N, which is the number of months. Okay, so N multiplied by 70 is equal to 4,800 minus 250. So subtracting 250 from both sides. Okay, so 4,800 minus 250, and we get 4,550. Okay, so therefore N is equal to 4,550. We're going to divide that by 70. Okay, to get N, and we get 65. So she's going to take 65 months to repay the loan in full. Question 28F. A charity seeks to raise money by telephoning people at random from a call center and asking them to donate. Over the years, this charity has found that the amount of money raised, $A, is related to the number of telephone calls made, N. A graph of this relationship is shown. It cost the charity $2,100 per week to run the call center. It also costs an average of 50 cents per telephone call. So part 1, write an equation to represent the total cost, C, of running the call center for a week in which N phone calls are made. So that one's a fairly straightforward one. C, that's the cost, is equal to, so we have a fixed cost here of $2,100. That needs to be paid basically up front, and every telephone call is going to cost 50 cents or half a dollar. So we'll leave everything in dollars, of course. So that's one of the things, just it's a subtle point, but this 50 cents really needs to be expressed in dollars because all amounts are in dollars. So we use the same units. So this will be plus 0.5 N. So part 2, by graphing this equation on the axes above, Determine the number of phone calls the charity needs to make in order to break even. Okay. So this is a linear equation. This C equals 2,100 plus 0.5 n. This is the y-intercept, 2,100. Even though it's written back to front, in fact, I could write it. I'll just write it actually maybe off to the side here. I could write it like this, 0.5 n plus 2,100. So this is in the form y equals mx plus c. So gradient is 0.5 and the y-intercept is 2,100. So 1, 2, 3, 4, 5. Okay, so it looks like we're going to be starting from here. Okay. And the gradient is 0.5 n. So in other words, for every 200 we go across, we go up 100. Okay, so 1 there. Okay, for every 200 across, okay, we go up another one. Okay, 200 across, we go up another one. Okay, 200 across, we go up another one, and so on. Okay, so it's an easy way of graphing without even having to use a table of values, which is very handy. Okay, so just interpreting what it meant, what 0.5 n means. Okay, so there's our line that represents cost. So this is our cost. And we need to work out where the break-even point is. So that's the point of intersection. Okay, so that's just here. And that will be 700. Okay, so 700 calls need to be made. Okay, determine the number, 700 calls. Question 29E. A diver springs upwards from a diving board, then plunges into the water. The diver's height above the water as it varies with time is modeled by a quadratic function. Graphing software is used to produce the graph of this function. Explain how the graph could be used to determine how high above the height of the diving board the diver was when he reached the maximum height. So I think there's 2 points here to note. Okay, we have the y-intercept, which is 8, so that's 8 meters. So that implies here that the diving board is 8 meters. So why don't we start off with that? So okay, and just before I continue, why is that of importance? The x-axis represents time. Okay, so the y-intercept equals 8, which means that is the initial height of the diver. Above the water. Okay. In fact, I might just put here 8 meters. Now, the other point here that's of importance is the vertex. Okay, so this is the peak of the graph, or the peak of this parabola. Okay, just here. So that's roughly roughly at the half second mark, or the 0.5 second mark. And we can see that it's around, probably around the 9.2 meter mark. So the vertex, okay, is at 9.2 meters. The difference then between the vertex and the y-intercept gives us how high above the diving board. Okay, which is 1.2 meters above the diving board. Question 4. A company manufactures phones. the company's income equation and cost equation are drawn on the same graph. Which region of the graph is the profit zone? So first of all, W and Y make no sense because the zones that we're talking about must be between these two lines. So they're gone. So option A is gone and option Y makes no sense. So it's between B and D now. A profit is made when the income is greater than the cost. So this is zone X. So that's going to be option B. Question 18. The value of E varies directly with the square of S. So this means that E is equal to K multiplied by S squared. It is known that E equals 20 when S equals 10. This line here enables us to find the value of K. So E equals 20 when S equals 10. So K times 10 squared. So we can solve for K is equal to 20 over 10 squared. Okay. 20 over 10 squared, and we get 1 on 5 or 0.2. So E is equal to 0.2 multiplied by S squared. So last part of the question, what is the value of E when S equals 40? So E is equal to 0.2 times 40 squared. Entering that into the calculator, 0.2 times 40 squared, and we get 320. Option C. Question 29b. The mass m kilograms of a baby pig at age x days is given by m equals a outside of 1.1 to the power of x, where a is a constant. The graph of this equation is shown. So part 1, what is the value of a? Now the value of a occurs when x equals 0. So that's just the y-intercept, in fact. So looking at the y-axis, looking at where the graph intersects the y-axis, we have a is equal to 1.5. Part 2, what is the daily growth rate of the pig's mass? Write your answer as a percentage. Now we can either use the graph for that or we can just use the equation. In fact, it's probably easier to use the equation in this instance. And the way I'm going to write the equation is just a slight variation of the original equation. So we know we have the value of a now, which is 1.5, multiplied by, now instead of writing 1.1, I'm going to write this as 1 plus 0.1 to the power of x. Now this is quite interesting. This almost looks like the compound interest formula, doesn't it? So I'm going to write this a little bit differently again. 0.1 is the same as, or it's equivalent to 10%. So we can see here that as each day goes past, the mass is in fact increasing by 10%. Let me just write this one more time. Again, a different way, just so you can see that this is really just 110% to the power of x, which is just an increase of 10% each day. So the daily increase or the daily growth rate is equal to 10%. Question 17. The graph of the line with equation y equals 6 minus 2x is shown. When the graph of the line with equation y equals x plus 3 is also drawn on this number plane, what will be the point of intersection of the two lines? Now, this could either be solved using algebra, or we could just draw in the line. Now, let's draw in the line y equals x plus 3. That has a y-intercept of 3, so it'll be there. And it has a gradient of 1. So that means it's a line that kind of does this, right, in this direction. That means that it's going to cross the x-axis at x equals negative 3. Now, if we get a ruler and just mark in approximately where this line's going to go. Okay, so just take care with this. Okay, and that'll give you some idea of where the two lines in fact intersect. So that's going to be this point here. So that looks like x equals 1, y equals probably 4 actually. Yep, it's probably closest to 4 there. 1 comma 4. So option B. Question 28a. Temperature can be measured in degrees Celsius C or degrees Fahrenheit F. The two temperature scales are related by the equation F equals 9C on 5 plus 32. Part 1. Calculate the temperature in degrees Fahrenheit when it is negative 20 degrees Celsius. So we just need to substitute negative 20 for C, or for the variable C in the equation. So F is equal to 9 multiplied by negative 20 all over 5 plus 32. Now, entering in that expression in the calculator. Okay, so 9 multiplied by negative 20 over 5 plus 32, and we get negative 4. Which is negative 4 degrees Fahrenheit. Part 2. Solve the following equations simultaneously using either the substitution method or the elimination method. So we could actually use either quite easily. In fact, it doesn't really matter. I think the substitution method may in fact work better here. And the reason for that is because of this second equation here. When you're solving an equation simultaneously using algebra, the idea is that we try and knock out one type of variable. You got the variable f and the variable c, and that complicates things. We just want one equation with one type of variable, either all letter f's or all letter c's, not a combination. Now, because f equals c, why don't we go back to equation number 1? Instead of writing letter f there, cross that off and we can put letter c in its place, since c and f are equal to each other. Okay, so using the substitution method, okay, we could write it as c is equal to 9c over 5 plus 32. Now, it can get quite complicated when you have fractions. So I guess the first thing to do is maybe multiply everything by 5, and that eliminates the fraction. So why don't we do that first? Okay, so 5 times c is 5c. 9c over 5 multiplied by 5 is just 9c. Okay, and 32 multiplied by 5. Okay, so 32 multiplied by 5 is 160. Now you have what appears to be a two-step equation. Let's collect the like terms. In fact, let's collect the variables on the left-hand side and keep the constant on the right-hand side. So the 160 stays put. Let's move the 9c over. So 5c minus 9c is equal to 160. So 5c minus 9c is negative 4c is equal to 160, and dividing everything by negative 4, okay, c is equal to, so I've just put it on the same line there to save a bit of space, is equal to 160 divided by negative 4, and that equals negative 40. Now, I'll just sort of complete it there. So therefore c is equal to negative 40. Now if c is equal to negative 40, what must f equal? Well, f equals c. Therefore, f also equals negative 40, since f equals c. Now there's a part 3 to this. It's on another page. Okay. So part 3. The graphs of f equals 9c on 5 plus 32 and f equals c are shown below. So there's the graph. So what does the result from part 2 mean in the context of the graph? Okay, so this is the result from part 2. Right, this result here. C equals negative 40, f equals negative 40. That's the result from part 2. In fact, just to quickly, I guess, just to demonstrate the idea, okay, if we extend this line a little bit further, so we're basically, what do you think is going to happen if I extend both of these lines as far as I can possibly go? What do you think is going to happen? The lines are going to, right? They're going to intersect, aren't they? So it's sort of going down into the question there, into the text. But the result from part 2 is a point of intersection. Okay. Okay. Of the two lines at the coordinate. What do you think the coordinate's going to be? Negative 40, negative 40, comma, negative 40. Question 28e. A movie theatre has 200 seats. Each ticket currently costs $8. The theatre owners are currently selling all 200 tickets for each session. They decide to increase the price of tickets to see if they can increase the income earned from each movie session. It is assumed that for each $1 increase in ticket price, there will be 10 fewer tickets sold. A graph showing the relationship between an increase in ticket price and the income is shown below. Okay, so that's the graph. And the question continues on the next page. So I might just the graph side by side there. Yep. So part 1, what ticket price should be charged to maximize the income from a movie session? So we'll go back to the graph, and what we're interested in is obviously the vertex of this parabola. Okay. And that corresponds to the maximum income that can be earned. So we'll need a ruler. Okay. So if we project across, okay. So it's just one step below 2,000. Now there are 1, 2, 3, 4. There's 5 intervals between 1,800 and 2,000. So there's a $200 difference. 5 intervals, that's $40 per interval. So 1, 2, 3, 4. 4 times 40 is 160. 160 plus 1,800 is $1,960. So the ticket price, what ticket price should be charged to maximize the income from a movie session? Each ticket currently costs $8. But the graph talks about an increase in ticket price. And the vertex of the graph corresponds to an increase in ticket price of $6. So the answer to this one would be $14 per ticket. So part 2, what is the number of tickets sold when the income is maximized? And this goes back to the original question. So a movie theatre has 200 seats. We'll see 1 ticket, 1 seat. And we know that when there's an increase in the price of tickets, for each $1 increase that is, there's 10 fewer tickets sold. So let's go now to the graph. Just go back to the part of the graph that corresponds to the maximum income, which is $1,960. So each $1 increase in ticket price is 10 fewer tickets. So let's set this up. We're starting off with 200 tickets originally, and we're subtracting how many lots of 10. So for every $1 increase, it's 10 tickets. 10 multiplied by, so we're talking about a $6 increase in price. Okay. Okay, so 200 minus 10 times 6 is equal to 200 minus 60 which equals 140 tickets sold when the income is maximized. So part 3, the cost to the theatre owners of running each session is $500 plus $2 per ticket sold. Calculate the profit earned by the theatre owners when the income earned from a session is maximized. So we'll need to use part 1 and part 2. So we know $14 per ticket, 140 tickets, and the cost is $500, obviously to run the movie, plus $2 per ticket sold. So profit is equal to the income minus the expenses. So the income, we already know what the income is. Okay, we can get that from the graph. In fact, the income maximized, when the income is maximized, okay, it's $1,960. So we can read that from the graph. Okay. Minus the expenses, and the expenses, okay, I'm going to put that in brackets, $500 plus $2 per ticket sold, so it's 2 times 140 tickets. Entering in that into the calculator. Let's see what we get. So 1960 minus 500 plus 2 times 140, so notice that's in brackets, is 1,180. Okay, now just one quick side note. If you don't want to use the graph to work out that it's $1,960 when the income is maximized, if you work out that it's $14 per ticket, okay, I might just quickly calculate this. So $14 per ticket multiplied by the number of tickets sold, which is 140, is also 1,960. So that's just an alternative way of coming up with the maximum, the maximum income. Question 30b. The cost of a jewelry box varies directly with the cube of its height. A jewelry box with a height of 10 centimeters costs $50. Calculate the cost of a jewelry box with a height of 12 centimeters. So this is a formula, it's a direct variation formula, where it's going to be in the form y is equal to k multiplied by x cubed. Okay. And we need to find the value of k before we can then answer this question. Now we do have some data already. We know that a jewelry box with a height of 10 centimeters costs $50. So let's let x represent the height and y represent the price. So $50 is equal to k multiplied by 10 cubed. K is equal to 50 divided by 10 cubed. Hence, k is equal to, okay, let's work this out, 50 divided by 10 cubed, and we get 0.05. Now we can proceed to answer this question. Calculate the cost of the jewelry box with a height of 12 centimeters. So y is equal to 0.05 multiplied by 12 centimeters, and we need to cube that. Multiply all that together. So 0.05 multiplied by 12 cubed, and we have $86.40. So therefore, the cost is $86.40. Question 4. Which graph best represents the equation y equals x squared minus 2? So we know it's going to be a parabola. X squared is a parabola that looks like this, concave, up. So it's most certainly not going to be option B nor option D. Now, this -2 or this -2 indicates a y-intercept. And there's only one graph that has a y-intercept of -2, which is option A. So the answer is A. Question 27b. Find the values of x and y which satisfy the following equations simultaneously. We're going to use the elimination method. So I'm going to change the first equation so that it looks like the second equation somewhat. So instead of y equals x plus 5, I'm going to write it as y minus x is equal to 5. So I've moved the x over and it becomes a negative x. Now the second equation, I'm just going to leave it as it is. So just write it underneath. Notice now that we have two equations where one of the terms is identical, which is the negative x term. Now we'll apply the elimination method and just subtract the corresponding terms, one from the other. So y minus 3y is negative 2y. Now negative x minus negative x, or minus minus negative x, that cancels. And then we have equals 5 minus 7, which equals negative 2. Now making y the subject of the formula, y is equal to negative 2 divided by negative 2. Therefore, y is equal to 1. Now we can substitute y equals 1 into any one of these two equations to find the value of x. So using y equals x plus 5 to solve for x. Now y is 1, we've already found that. So 1 is equal to x plus 5. We subtract 5 from both sides. So 1 minus 5 is equal to x. Therefore, x is equal to negative 4. Therefore, the solution to the simultaneous equation is x equals negative 4, y equals 1. Now, if you have a little bit of time, we probably should substitute these two values into each of these equations and make sure it works. So negative 4, so x equals negative 4. If you substitute that into the first equation, negative 4 plus 5 is definitely equal to 1. So that works there. What about the second equation? 3y, so that's 3 times 1, that's 3. Minus 4. Okay, in fact, I'll just show you on the calculator. Okay, so 3 times 1 minus, now x is negative 4. We get 7. We get 7. So this answer is correct. Question 27D. The graph shows the cost, P dollars, charged by two companies for the hire of a minibus for X hours. Both companies charge $360 for the hire of a minibus for 3 hours. So part 1, what is the hourly rate charged by company A? Now just before I answer this question, I've actually changed the pronumerals to make them a little bit more compliant with the current syllabus. So the old syllabus, or the previous syllabus, will use y equals mx plus b, but we're really meant to be using y equals mx plus c. So that's why these pronumerals here have been changed. Let's get back to part 1. What is the hourly rate charged by company A? Now notice the line for company A starts off at the origin, so it's $0 for 0 hours. There's no booking fee or anything like that. For 3 hours, it costs $360. So hourly rate is really equal to 360. Divide that by 3, and that's equal to $120 per hour. Now part 2, company B charges an initial booking fee of $75. Write a formula in the form P equals mx plus c for the cost of hiring a minibus from company B for X hours. So if you look at the graph of company B, we can see that there's clearly a y-intercept there. In fact, that's what represents the booking fee. So
we could write it this way, and we know that it's $360 for 3 hours. So let's just substitute in what we know into this equation. 360 is equal to m, we don't know what the gradient is, which represents the hourly rate, multiplied by 3 hours plus 75, which is the initial booking fee. Let's rearrange this formula. Okay, so 360 minus 75 is equal to m times 3. So m is equal to 360 minus 75. Then we're going to divide that by 3. So m, the gradient, or which represents the hourly rate, okay, is equal to, so 360 minus 75 divided by 3, and we get 95, which is in fact the hourly rate, $95 per hour. Therefore, the equation is P is equal to 95x plus 75, which is the initial booking fee. So part 3, a minibus is hired for 5 hours from company B. Calculate how much cheaper this is than hiring from company A. Okay, so there's company B. Beyond 3 hours, we can see that company B is going to be cheaper. So let's just work out the cost for 5 hours for both companies and then find the difference. Okay, so the cost, let's work out company A first. Okay, it's going to be 5 hours multiplied by $120 per hour. Okay, and that's going to be equal to 5 times 120, $600 for the 5 hours. Now let's work out company B. Okay, and we can use our equation that we used from part 2. Okay, so we'll definitely need that. So 95 multiplied by 5 hours plus the booking fee of $75. Okay. So 95 multiplied by 5 plus 75, and we get $550. Okay, so 600 minus 550 is equal to $50. Therefore, company B is cheaper by $50. Question 29C. When people walk in snow, the depth, d centimeters, of each footprint depends on both the area, a square centimeters, of the shoe sole and the weight of the person. The graph shows the relationship between the area of the shoe sole and the depth of the footprint in snow for a group of people of the same weight. So part 1. The graph is a hyperbola because d is inversely proportional to a. The point P lies on the hyperbola. Find the equation relating d and a. So it's inversely proportional, which means the formula is going to be d is equal to k over a. So dependent variable, independent variable. So a is the independent variable, which is on the x-axis. Now we need to use point P to determine the value of k. So substituting in this point, this coordinate, this is 300 on the x-axis, and when the area is 300, the depth is 15. So 15 is equal to k over 300. Multiplying both sides by 300, we have k is equal to 15 multiplied by 300. And we get 4,500. Therefore, the equation is d is equal to 4,500 over Part 2. A man from this group walks in snow and the depth of his footprint is 4 centimeters. Use your equation from part 1 to calculate the area of his shoe sole. So we're going to use this equation here and we're going to solve then for A. So depth is 4 centimeters is equal to 4,500 over A. Let's multiply both sides by A. So we can do this in 2 steps so you can see how to solve this. 4 times A is equal to 4,500. Then we can divide both sides by 4 to make A the subject of the formula. It's just easier to write it in division, using division notation instead of fraction notation. And dividing one by the other now. So 4,500, which is our value of K, divided by 4, we get 1,125 square centimeters as the area of his shoe sole. Question 31. A rectangle has width W centimeters. The area of the rectangle A in square centimeters is A equals 2W squared plus 5W. The graph of A equals 2W squared plus 5W is shown. Okay. So part A, explain why in this context the model A equals 2W squared plus 5W only makes sense for the bold section of the graph. And I think if you look on the x-axis here, the W here represents the width of a rectangle. The width makes no sense if the width is a negative number, like -1 centimeters. Okay, so Okay, so anything to that effect, there's 1 mark. Now the area of the rectangle is 18 square centimeters. Calculate the perimeter of this rectangle. So if we're talking about perimeter, and I might just sketch a rectangle here. Okay, there's width and there's the length. So we want the distance around the rectangle. So let's first of all work out the width from the area. Okay, so we're told that the area of this rectangle is 18 square centimeters. So let's use the graph then to work out what the width should be. So using a ruler, okay, so there's 15 square centimeters, 16, 17, 18. Okay, so the y-axis represents the area of the rectangle. Okay, you draw a line across, find out where it intersects with the graph. Okay, if you project downwards, okay, you can see there that the width must be 2. Okay, so using the graph, okay, and I guess just to show you working out, just to make sure that you've shown you working out, okay, you can see that you've used the graph there to project across and then project down. Using the graph, okay, a width of 2 centimeters gives an area of 18 square centimeters. Okay. So that means then that the width is 2. Okay. Now we need to work out the length. Okay. So area is equal to width times length. The area of the rectangle is 18 square centimeters. So 18 is equal to, now the width is 2 multiplied by length. Therefore, length is 9 centimeters. So what's the perimeter? Hence the perimeter is equal to 2 times 9, because you have a 9 up here and you have a 2 here. Right? 2 times 9 plus 2 times 2. Okay, so that's 18 plus 4. Therefore, perimeter equals 22 centimeters. Question 33. The time taken for a car to travel between two towns at a constant speed varies inversely with its speed. It takes 1.5 hours for the car to travel between the two towns at a constant speed of 80 kilometers an hour. So I'm just going to underline the word inversely there. Calculate the distance between the two towns. Now, distance is equal to speed multiplied by time. Now, we can draw one of these to help us. So this is the distance, speed, time triangle. Okay, so distance is equal to speed multiplied by time. Time is equal to distance over speed. Okay, speed is equal to distance over time. So distance is equal to the speed, 80 kilometers an hour, multiplied by time, and the time is 1.5 hours. Multiplying those two numbers together, okay, 80 multiplied by 1.5, and that's 120 kilometers. So the two towns are 120 kilometers apart from each other. Part B. By first plotting 4 points, draw the curve that shows the time taken to travel between the two towns at different constant speeds. Now, we know that the relationship is an inverse one. In other words, if we double the speed, we halve the time taken, and that makes sense, doesn't it? We know at 80 kilometers an hour, okay, it takes 1.5 hours to get from one town to the other. If we halve the speed, so instead of traveling at 80 kilometers an hour, we travel at 40 kilometers an hour. Okay, it's going to take double the time. That makes sense. You slow down, it's going to take longer. It's going to be double 1.5, so that'll be 3 hours. Now, if we halve the speed again, in other words, half of 40, we're going to travel at 20 kilometers an hour. It's going to take double the time again. So instead of 3 hours, it's going to take 6 hours. Now, we need one more point. So if we halve 20, you get 10. We don't have enough, the y-axis isn't long enough to put 12 hours to plot the point there. So we need a point in between, because the question clearly states we need to plot 4 points. Now, if we go back to the distance, speed, time triangle, we need the formula in terms of time. So time is equal to distance over speed. We know the distance, which is 120 kilometers, over, let's pick a point, let's say 60 kilometers an hour. So 120 kilometers over 60 kilometers an hour equals 2 hours. Okay, so we can plot another point here. So that's 60 kilometers an hour, it's going to take 2 hours. We now have 4 points. We can now draw the curve. So might just this is probably best done with pencil. Okay, something like that, and that'll give you your 3 marks. Question 36. A small business makes and sells birdhouses. Technology was used to draw straight line graphs to represent the cost of making birdhouses, C, and the revenue from selling birdhouses, R. The x-axis displays the number of birdhouses and the y-axis displays the cost or revenue in dollars. So there's the graph. Part A, how many birdhouses need to be sold to break even? So this is where the revenue equals the cost. So just find where they intersect, project down to the x-axis, and we can see here that 20 birdhouses need to be sold in order to break even. Break even means you're not making a loss or a profit. So the answer is 20. Now part B, by first forming equations for cost and revenue, determine how many birdhouses need to be sold to earn a profit of $1,900. So profit is the difference between revenue and cost, and it's going to be 1,900. So we need to form these two equations and then form another equation where R minus C is equal to 1,900. So let's do this first. So let's work out the revenue first, or the equation for revenue. Okay, so that's the solid line. Okay, the y-intercept is 0, so this is an example of direct variation. Okay, so it's just going to be in the form y equals mx. Okay, so the gradient, okay, is equal to rise over run. Okay, so we can just choose a convenient right angle triangle. So we might just choose this one here. The run is 10, and the rise is 400. So if you go up on the y-axis, it goes up in steps of $100. Okay, so that's going to be 400. So the gradient is 40. Okay, y-intercept is 0. Therefore, revenue is equal to 40x. Now let's have a look at the equation that represents the cost. And we're going to do the same thing again. Let's work out the gradient first. Okay. So the cost is the dotted line. Let's find a convenient right angle triangle. We might use this one here. Okay, so you can see where I'm pointing here. So the run is 20. Okay, run is 20. And the rise, 1, 2, 3. Okay, that's $300. Okay. 300 divided by 20 should give us 15. Okay, and the y-intercept is here, 500. Therefore, cost C is equal to 15x, our gradient times x, plus 500. Now what we're going to do is form another equation and solve for x for the profit. Okay, so profit. Okay, R minus C is equal to $1,900. Okay, so the revenue is 40x minus the cost, which is 15x plus 500 is equal to 1,900. Let's now expand the brackets. 40x minus 15x minus 500 is equal to 1,900. Let's now combine the like terms. 40x minus 15x is 25x. And 1,900 plus 500, so this 500 is going to move over. Right? And I'm going to get 1,900 plus 500 should be 2,400. X is equal to 2,400. We're going to divide that by 25. So this 25 is going to be used to divide the 2,400 by 25. So, okay. 2,400 divided by 25, and we get 96. Therefore, need to sell 96. Just be careful anytime you write anything that you must stay above this line and you must stay inside this dotted line here.
Question 1. Which of the following could represent the graph of y equals negative x squared plus 1? So let's have a look at the options quickly. Option A, that's a straight line. This one is in the form y equals mx plus c. C is the y-intercept and m is the gradient. Okay. Look at part B. Okay, a graph that starts sort of from the left-hand side, very close to the x-axis, very low or very small value, rising up, going through 1 on the y-axis, and then rising at a very sharp rate. On the right-hand side there, this one is an exponential function. So this one's really of the form y equals a to the power of x, where a is in fact a number greater than 1. Okay, so this one's an exponential. Part C, okay, sort of a U shape, okay, that's a parabola. This one's concave down, so that means that there's a negative involved. Okay, this one is of the form y equals ax squared plus c. Now, the value of a here determines whether it's concave up or concave down. So in this case, okay, it's concave down, so it's actually going to be a negative number. Okay, so it's actually negative x squared plus c. C is the y-intercept, and we can see that the y-intercept here is 1. So it's y equals negative x squared plus 1. So it's option C. But let's have a look at option D, just for completeness. This one, a graph that sort of has two branches there, that sort of gets close to the y-axis, doesn't quite touch it, or gets close to the x-axis but doesn't quite touch it. So we call that asymptotic, or sort of approaching an asymptote. This one is a hyperbola, okay? And this one's of the form y equals k on x. Okay, so you might recall having seen these. So it's option C. Question 19. A fence is to be built around the outside of a rectangular paddock. An internal fence is also to be built. The side lengths of the paddock are x meters and y meters as shown in the diagram. A total of 900 meters of fencing is to be used. Therefore, 3x plus 2y equals 900. The area A in square meters of the rectangular paddock is given by A equals 450x minus 1.5x squared. The graph of this equation is shown. So here it is. Okay, so you can see that it's a parabola, a concave down one. Let's have a look at part A. There's a few parts of this question. If the area of the paddock is 30,000 square meters, what is the largest possible value of x? Okay, so this is where we go to the y-axis. Okay, so let's go to the graph, go to the y-axis. The y-axis represents area. Okay, so we want to find the largest possible value of x. So if we take a ruler, okay, and just project across, okay, so that's 30,000. So it looks like we have two answers here. X is 100, okay, 100 meters, or 200 meters. Okay, so the largest possible value of x is 200. Okay. I'm not going to mark the graph because, just in case if I need it for a subsequent part, it's only worth one mark. I don't need to show any working out. You can just read it straight off the graph. Let's have a look at part B. So just put that there. So part B, find the values of x and y so that the area of the paddock is as large as possible. Now, you can use part A to help you with this one, or at least the idea from part A. If you go back to part A, it says if the area of the paddock is 30,000 square meters, what is the largest possible value of x? Let's reverse it. What is the smallest possible value of x? And get our two values. So the 200 meters that we found here, let's find the smallest possible value of x. Okay, so I think originally I said for part A that the smallest value was 100. The largest value is 200. The vertex is in fact midway between the two, and that's going to be at 150. Okay, but we can read it straight off the graph as well. Okay, so the vertex x equals 150 meters, and that's from the graph. Probably the easiest just to read it from the graph. But it was interesting to note that it was exactly midway between the 100 meter mark and the 200 meter mark. Okay, so if we found x equals 150 meters, we need to now find the y value. Let's go back to our original diagram. Okay, so we found x is equal to 150 meters, but we need to find the value of y. And we're going to use this equation here, 3x plus 2y equals 900, to calculate the value or to determine the value of y. Okay, so I'll just go back to part B. Okay, so 3x plus 2y equals 900. Okay, so moving ahead, okay, so 3 times 150 plus 2y is equal to 900. Okay, so we need to solve this equation for y. So 3 times 150, okay, that's 450 plus 2y is equal to 900. Okay, I think we're getting close to our solution. If we subtract 450 from both sides, 2y is equal to 450. Okay, hence y is equal to 450 divided by 2. Okay, which is equal to 225. Okay, so therefore x equals 150, y equals 225. And part C, just for 1 mark, using your values from part B, find the largest possible area of the paddock. Well, let's go back to there's the diagram of the paddock there. That's 225 meters. That's 225 meters all the way along. The internal the divider doesn't really matter in this case. It's just the area of the large rectangle. So this whole rectangle here, it's just x times y. Okay, so area is equal to xy, okay, which is equal to 150 multiplied by 225. Okay, 150 multiplied by 225, and we get 33750. Square meters as our maximum or the largest possible area of the paddock. Question 24. There are 2 tanks on a property, tank A and tank B. Initially, tank A holds 1,000 litres of water and tank B is empty. Part A. Tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water in tank A is modelled by V equals 1000 minus 20t, where V is the volume in litres and t is the time in minutes from when the tank begins to lose water. On the grid below, draw the graph of this model and label it as tank A. Okay, so there's our grid. Okay, let's go to our equation. So this is a linear equation, so it's going to produce a straight line. The 1000 represents the y-intercept. Okay, so basically we're looking for the term without the t, and that's our y-intercept. So I'm just going to put a mark there to represent our y-intercept. And it's losing 20 litres of water per minute. So we need another point. So let's go back to our grid. We'll just pick a convenient value of t. So let's say, I don't know, 50. And let's see how much water is in the tank at the 50-minute mark. Okay, so V equals 1000 minus 20 times 50. And we get 0. So the tank is in fact empty at the 50-minute mark. Okay, well, after 50 minutes. So just going to put a little cross there, so a little mark to indicate that point. And we have 2 points, so let's draw in our line. Okay, so I would recommend that you use a clear ruler. Okay, so just makes it easier. You can see through it. So there we go. And let's label it as tank A. Actually, I might just put it up here. Okay. All right, let's have a look at part B. Tank B remains empty until t equals 15 when water is added to it at a constant rate of 30 litres per minute. So by drawing a line on the grid on the previous page or otherwise, find the value of t when the 2 tanks contain the same volume of water. Okay, so I think we'll just use the graph. It's probably going to be easier. Okay, so we know at the 15-minute mark, okay, tank B is initially empty and it's filling. So at the rate of 30 litres per minute. Okay, so what we need to work out is another point on this grid. So we can draw the line that represents the volume of water in tank B at a given point in time. So what we can say is, well, let's just say after 20 minutes, let's work out how much water's in tank B, and then that way we can plot our point. So, okay, so so it's 30 litres per minute times 20, which equals 600 litres. So on the grid, when T is in fact equal to 35. Okay, so this 20 minutes just means that since tank B started to fill, so it's from when tank B started filling, okay, which is from this point here. After 20 minutes from this point, tank B has 600 litres. So that's going to be at the 35-minute mark, and we'll just go to this point here, and just put a little X there, just to mark the volume, to mark the point where there's 600 litres after 35 minutes, okay, in tank B. Let's join the points. So we'll draw in our line. Okay, so that's that there. Okay, and I might just continue that along. Yep. And let's call that one tank B. All right. And to answer the question fully, we need to work out, obviously, at what point what value of T when the two tanks in fact contain the same volume of water. So that's the point of intersection. That's what we're trying to find. So it's very similar to those break-even type analysis questions where we're looking for the point where the profit equals the loss, except this is now applied to water. So this is the point that we want there. Okay, so if we project downwards, okay, so looking at the grid, the volume of water in both tanks is equal at the 29-minute mark. Okay, so from the graph, in both tanks at T equals 29 minutes. Okay, part C, using the graphs drawn or otherwise, find the value of T where T is greater than 0. So that means T can't equal 0. When the total volume of water in the two tanks is 1,000 litres. So that means that whatever's in tank A plus whatever's in tank B is equal to 1,000. And so what we'll need to do is to look at various points sort of on the grid, and this is where a ruler would come in handy as well. So let's say at the 15-minute mark, okay, we have 700 litres of water in tank A, 0 litres of water in tank B to give you a total of 700. Okay, so if you're say moving along to say the 25-minute mark, you've got 300 litres of water, okay, in tank B, and 500 litres of water in tank A. That's 800, so still doesn't get us to the 1,000 litre mark. Okay, so if you move along, in fact, in trying these various points, and you'll get to a nice convenient point here. So let's say at the 45-minute mark, you've got 100 litres of water in tank A, and you've got 900 litres of water in tank B, and that gives you your 1,000 litres. So okay, that occurs again at the 45-minute mark. Okay, find the value of T. Okay, so okay, and that's from the graph. You could solve this using algebra, but I think it's just easier using the graph. Question 33. The graph shows the number of bacteria, Y, at time n minutes. Initially, when n equals 0, the number of bacteria is 1,000. So part A, find the number of bacteria at 40 minutes. And we'll just have a quick look at part B, so it follows on the next page. Part B, the number of bacteria can be modelled by the equation y equals a times b to the power of n, where a and b are constants. Use the guess and check method to find, to 2 decimal places, an upper and lower estimate for the value of b. The upper and lower estimates must differ by 0.01. All right, so let's go back to the graph and part A. So it says find the number of bacteria at 40 minutes. So on the x-axis here, let's locate the 40. From there, just all the way, sort of go all the way up vertically to the graph until you strike the graph, and then project across, and you see that number of bacteria is 4,000. So all you need to do is just write down 4,000. All right, let's have a look at the next part here. So back to part B. Okay. So we have the equation y equals a times b to the power of n. Now the a represents the initial value. In other words, when n equals 0, b to the power of 0 is just 1, and therefore, a times 1 is just a. So a represents the value of y when n equals 0, sort of another way to put it. So going back to our graph, okay, so n equals 0 means that's the initial sort of starting value, the initial number of bacteria, and that's going to be 1,000. So a equals 1,000. Hence, the equation is y equals 1,000 multiplied by b to the power of n. Okay. Now what we need to do is to go back to our graph, because we need to estimate a value for b. Okay. We need to pick another point on the graph, and just pick a convenient point. It can be any point, but I might go back to the point that we initially found in part A, which was this point, 4,000 bacteria when n equals 40. So this here is a very convenient point to use. So we're going to substitute the coordinates of that point into this equation, and a bit of guess and check. Hopefully we can find a value for b, or at least narrow it down so that it's between sort of the two values, the upper and lower estimates by 0.01. So the difference between them. All right, so what we're going to do is we're going to use, okay, so when, in fact the best way to write it is that when n equals 40, okay, y is equal to 4,000. And in fact that could be, or may be, a reason why part A is the way it is. It sort of gives you a clue that that's a very convenient point to use to help us with part B. Okay, so we have 4,000. Okay, y is equal to 1,000 times b to the power of n, or b to the power of 40. So n is 40. When n is 40, the number of bacteria is 4,000. If we divide both sides by 1,000, just to sort of clean up the algebra, we end up with 4 is equal to b to the power of 40. Now, we're probably going to need a little bit of extra space here. I like to set this up a little bit first before we use guess and check, but you could use guess and check at this point here if you like, to save a bit of space. So I need to find a value for b, so when I raise it to the power of 40, I get 4. All right, this is where you need to spend a minute, just try a few values on your calculator. So it has to be greater than 1, so I could try 1.1 to the power of 40, and we get 45, so it's clearly way too big. Okay, so we need it to equal 4. So when b equals 1.1, okay, y is equal to 45. So 1.1's way too big. Let's go back and try 1.01. That's way too small. Okay, so b equaling 1.01, y is equal to 1.49. Okay, we can try increasing that, say maybe to 1.05. Okay, we're getting closer, we're narrowing it down now. So B equaling 1.05, okay, Y is equal to 7.0, okay, and so on. So at this point, we'll probably get it pretty close. We've got 1.04. In fact, why don't we try 1.03 while we're at it? Yeah, there you go. So 1.03, 1.04. So when B is equal to 1.03, Y is equal to 3.26, and when B is equal to 1.04, okay, and I might just go back to my previous answer, is 4.8. Therefore, B must lie between 1.03 and 1.04.